This is one of two 3-inch drones that we're building lately. The other one is a Holybro Cocoot. This one is Diatone Mamba. The frame is the HGLRC VX145, same frame used on the XJB. Today we are soldering on a receiver. This is the Frsky R-XSR, pretty typical standard receiver, pretty much a piece of cake. So if you look at the board here, let's go ahead and get zoomed in. So this should be pretty simple. All you need to do is take a few wires from each one of the devices that you're going to solder on here, and then you're going to find the proper pad to attach it to. So for example, the receive pin, the transmit pin, power pins and such. So they all should be pretty easy to find. They all should have labels. This is going to be a little bit harder than I thought. Well, here I am at the Diatone website looking for the Mamba F405. I want to find something that matches my vehicle. Now, typically, and that's hard to say typically because there almost isn't it typically, but the first thing I'm going to do is I'm going to look up, just say like Diatone Mamba. I'll probably say like Diatone Mamba F4, but this one says F405. Okay, that's fine. So we'll say Diatone Mamba F405. And if I come over here, the first things I see, I can tell you when I click on some of these, is it's not going to be what I want. So I usually go straight for images because outside of the Holybro, if you watch the video that I'm doing in parallel here, that one has, it's an 18-page document. That's really pretty rare. Typically, I'm looking for a wiring diagram or a pinout diagram, and so I head straight for images. And so I start looking around and I see some stuff here and I go, oh, okay, there you go. Cool, look at this. Receiver just goes in here. Okay, this is going to be easy. But then I look at my board and it's not the same, you see? Then I start looking around. Let's go, how about this one? Okay, oh, what a beautiful documentation. So this is great. It even says Mamba on it, right? I'm almost good with it. I'm almost good, but wait a second. Something isn't quite right. I don't think I have that there. Now, maybe you could go, well, they probably kept him in mostly the same position. We could probably guess, right? But want to say, you know, maybe don't do that. So I end up over at the Diatone website. So here we've got the F405 V1 diagram. So I'll open that one up in a new page and I look at it and go, no. That's not even close. It's not even close to ours. How about the, mini, there you go. I need the mini one. So I go here and I look at it and this one looks pretty good. It's like, yeah, look at those pads. Wait, that's kind of weird. Okay, I don't have that, but maybe that's fine. Here is our OSD chip here. And then this is, well, actually this is probably what, a switching regulator or something. Anyways, this is not ours. So that's no good. Back to here. How about the Mamba F20? Nope, that's not it. F40? Nope. F405 V1 connection schematic diagram. How about that? Okay, look, there's that lumpy thing there. That's not ours. It's just not ours. And there's words. Look at that. That's definitely not ours. So you keep going through this. Mini connection schematic diagram. This one, that's got that little thing that we saw before sticking out of it. Hard to say, you know, hard to say. That doesn't seem like it's ours again because we've already kind of took a peek at this. Here's our Mark II. Hey, yeah, Mark II. Great. Look, there's that picture again. But we need a Mark III. And it's not here. I don't see it being here. And so this is a thing that I run into a lot. And maybe I'm looking in the wrong spot. So forgive me, Diatone, if I'm incorrect here. But my point is that quite frequently something is up, and maybe a speculation here is these companies are cranking things out so fast that the product hits the streets faster than they can make the documentation, and then maybe they get around to the documentation, but maybe the life cycle is so fast that sometimes they even skip the documentation because by the time they can get it done, we're already on to the Mark IV possibly. So maybe it won't even come out. I don't know. So we have to try to find it in a different way. And so thankfully, because of our community-based hobby industry that we're in, somebody will probably create a diagram. But I want to show you this though. This diagram that we just looked at here, this is the one that we see here we go, in the Mark III, and we've got Mamba system on it. It looks the same, so I want to kind of presume that it comes from the company. So somebody found this somewhere, but it is not on that page. So I might be lost and gone in how I'm trying to figure this out. But again, this is what I'm trying to say. You have to try to figure out what to do with this, and maybe you might even have to come down to resort to making some guesses. So this is the norm. Now, after you finally find your documentation and you're certain that it is the right one that matches your model here, now you can start getting into this to figure out what you need to do with the particular device that you're currently focused on. So we're going to go right here. We're going to go from ground. So this is a ground pad. Without having things labeled, you're going to have to count this, right? So here is our S. Here's this thing, S port. Wait, they got a label. Oh, I see. It's just like a circuit board label. Okay, so this is our S port. It's going to go right to here. They just don't show the wire actually connecting. Our S bus is going into this one right here, 5 volts and ground. Now, if you wanted to check this, this would be easy enough to corroborate, and maybe when we get back to the bench, we'll do this. Plug in the battery, and if I put a multimeter across these 2 pins right here, I should get 5 volts. Then now that we've determined where this goes, we need to determine what the outputs of this actually are. I can tell you that this is great documentation right here, because this is literally the way that the R-XSR is wired. But you might not know that for a fact, and you might not be so lucky to have a nice little diagram explaining it all. So you need this one. Now this diagram, I've been using this one for, it seems like years, since the R-XSR came out. It's a weird looking diagram, and I can tell you a lot of people new to this get really confused by it. What's happening here is they're showing you the R-XSR, and then they're showing you an XM Plus, actually, being used as a slave. They're showing you a couple different options here that you could have, but it kind of causes people to believe that they're missing something. Maybe I was supposed to get this in the bag? Is that I wonder how many calls they get saying, hey, I think I'm missing something. So here's what's up. This top one, the R-XSR, is the unit in the bag. This is an extra thing you could get, and what they're doing here is they're using it as a double, like 2 different ones. One is the slave, one's the master. Could be used for, let's say, a large RC aircraft that maybe the thing rolls over and you lose signal, so you put one on the top, one on the bottom. So just erase that part right there. So this S bus in, that doesn't even exist. Power, ground, S port, S bus. These are the only wires we need. This wire right here on S bus, when we get back to the bench, I'm going to show you that what we're going to do is we're going to actually pull this wire out of the JST connector. We're not going to cut it. We actually open the casing and pull the pin out so you don't have any stragglers left to potentially cause problems on the board. Okay, back to this diagram. So now that we know what comes out of here, in what order, and where it goes, now we can get back over to the bench and we can get to soldering. So like I said, if you want, you can test this to corroborate what the datasheet says. So if I get right 1, 2, 3, 4, right up here on this, then right to here, be careful, we should have 5 volts. Go ahead and open up your receiver, and I want to show you in here. It should be pretty clear based upon the drawing. Here is the piece of paper again that's got the diagram in it that we looked at. What you'll find is 2 sets of wires. This is pretty normal for all type of devices you're going to get for UAVs. I say it this way rather than drone devices because these things could be used by a lot of different people for a lot of different purposes. So they keep different cable types in there for all of the options that you might need. So this one here with the connectors on both sides, we don't need that one. We want this one right here. So as you can see, there's 5 wires here, and per our diagram, we only need 4 of those. So the one we want to get rid of is this white wire here. I can tell you that because if you look at the diagram, and if you want, you can plug this in. So right here is the bind button, and you can see that identified in the wiring diagram. Then you know the orientation of all the wires. You know that this one's supposed to be ground, power, S port, S bus, and this last one is the S bus in that we don't need. So we can go ahead and get rid of that one. Now, like I mentioned earlier, We're not going to cut it, we're going to get rid of it. So what you do is you just come in here with a knife, then you lift this tab up. Do not use your expensive pointy tweezers. Pull this out and take it away. So now it's gone. We don't have any risk of a clipped wire touching the board and shorting anything out. Next, what we're going to do is we're going to cut them about so long, strip and tin. When I clip these off, they're not much longer than a millimeter. That is to go along with the size of the pad. Don't cut them any longer than the pad, because the end might stick into some component and potentially damage something. So now our wires are all prepped. What we need to do is tin all these pads. Then the rest should be pretty darn easy. As long as you're fast, you should be able to just grab grabbing some solder off camera here. So I've got some solder on the tip, and the let's start with the ground one here. So you set it right where it's supposed to go, get over the top, and then come out. You don't have to be fast like a race. I'm just saying quick enough to where you're not poking and prodding at it to try to get it to be in there. Oops, I slipped a little bit. Hold on a second, because I don't want you to burn up what flux is already there. If you spend a lot of time dinking around with it, then remember, just add a little bit more so that you don't have spikes sticking out of it. Oops, look at that. See that? Just brush it away. Now I'm going to go ahead and grab my tweezers, because this is a little bit close quarters here. So if you can see what I'm doing, we come in here straight like this. Hold the wire just like so. Just a little bit on the tip. You don't need a big blob. Stay real steady. Solder it down. Then the next is our S-bus port for RC. That one is okay, but I feel like I would like to have a little bit more solder on it. I guess that's what I get. I grab the telemetry wire, S port. There we go. All right, that's it. Not very bad after you get all of the information sorted. That's quite frequently the hardest part of the whole mess. So I'm going to go ahead and clean this up really quick, and then we're not quite done yet, because remember what I've been talking about through all the videos, that we have these testing milestones along the way, so we know that if it is broken, what device caused it. Right there. So what I'm trying to do is not set the exposed circuit board on any other circuit or the carbon fiber. I say this over and over and over again, but everybody remember, carbon fiber is conductive. So if I were to lay this on the frame, I could easily short it out. Okay, so I'm going to plug it in, and what should happen is we get all the beeps, we get the lights, everything, you know, the same as it was before, and we get lights on the receiver. There you go. Then I think for the next video, we'll go ahead and bring back the Holy Bro Kakut build that we're working on as well, the other 3-inch drone, and then we'll bind both of those in the same video so you can see the process twice, and that'll be kind of nice. After that, we have the video transmitter and then the camera, and that is it.